Yes, we can see your screen right now.
Okay, is part of the screen being shown with the taskbar?
No, it comes
That's
up.
just
Yeah.
on mine. Okay, I gotcha. Okay, very good. I'm ready to go.
Yeah, thank you, Joe. Just
Okay.
a quick remind everybody. So we'll do questions at the end. Please, you can type on the Q&A your questions, and then we'll answer them at the end of the presentation. Okay. Thank you very much, Joe.
Okay, Vitor, thank you very much. I appreciate it. It's great to be here. We're going to talk about mixing it up, heterospermic AI. As Vitor mentioned, I am a University of Idaho faculty member. I'm an extension dairy specialist and a current member of the Beef Reproduction Task Force. And I'm also a member of the Dairy Cattle Reproduction Council and a former board member and president of that association also. So what are we going to do today? What we're going to talk about is shown on this slide. We're going to go through some really basic definitions to make sure we all have the same foundational material. We're going to hopefully answer the question, why do we mix semen for multiple males? Talk a little bit about the research perspective, and then also the commercial perspective of heterospermic AI. We're going to talk about available fertility data, and the key word there is available. And then we're going to talk about potential issues with the use of heterospermic doses. And then we're going to wrap it up for some final thoughts, and I'd be happy to answer some questions at that time. So we need to kind of set the stage. And what we're used to most is something called homospermic inseminations. And these could be conventional or sexed semen. And what we do is we're at the AI stud, as we're seeing here in the upper left picture, we're collecting semen using an artificial vagina. We could be collecting one ejaculate or two ejaculates in succession. And once those ejaculates meet certain criteria, pre-freeze and pre-processing, then that ejaculate will go ahead and it will go through a processing and semen cryopreservation. And then doses will be prepared. And we have in the bottom here, we have a straw. This is a 1/2 ml straw, but it could be a 1/4 ml straw. And we have a portion of the ejaculate from this male that we collected within this straw. And we only have semen from one male because I'm only showing one bull being collected. So that's homospermic. But we're here to talk about heterospermic. So what we have with heterospermic, and this could be conventional semen or sex semen, we have collection from multiple males that are occurring. So what we have here are 3 different bulls, and the bulls could be of the same breed, if that's desired, or different breeds, depending upon whatever is desired. And we are going to collect these males in the same exact way. We're going to use an artificial vagina for each one of these males. We're also going to then do our routine pre-processing analysis. And then, if everything meets the standards, we are going to mix the semen on an equal basis, equal sperm number basis, and then process it all the way through to freezing and storage. Now, the difference then, obviously, with this straw is this straw is going to have a mix or pooled semen within it. It will have sperm cells from each bull that you see here, again, ideally on equal numbers. So this would be a mix. This would be a heterospermic dose, or some people call it pooled semen. So now the question is, why would we want to do this? Why mix semen from multiple males? Well, the ejaculate is a heterogeneous population of sperm. And what do I mean by that? What I mean is not all sperm cells are going to be exactly the same. They're going to have morphological differences. Some will be very subtle, some will be very distinct. We know we have X and Y chromosome bearing sperm. That's the basis for our ability to sort semen, is our understanding of the difference between X and Y chromosome bearing sperms. We know that there's deviations in motility patterns, and those can be related to morphological differences, specifically head differences. And capacitation may occur at different rates within the female. Remember, capacitation are those events that need to occur to the sperm, specifically membrane modification and also motility modification, that will allow sperm to fertilize the egg. So what happens following heterospermic AI? We have this mix. We have this heterogeneous population within this straw. Well, what happens is semen from 2 or more males, after it's mixed on an equal basis, results in a disproportionate number of offspring sired by 1 male. So that means of those 3 males that we have in a straw, 1 is going to sire a high percentage of those offspring. And this has been shown to be true in rabbits, in swine, in birds, in cattle. But the reason for this phenomenon is unknown. We really don't have a good explanation as to exactly why this happens. However, heterospermic AI is an attempt to exploit the heterogeneity of sperm that I previously talked about. I'm going to say that again. Heterospermic AI is an attempt to exploit the heterogeneity of sperm that is normal to ejaculates that we collect. And the way we have to think is, could there be an advantage to early or late capacitating sperm, or longevity differences among sperm, or the ability of sperm from 1 male compared to other males to withstand freezing and thawing? Or what about the ability of males to withstand sex sorting, freezing and thawing? So that's where this idea of perhaps if we mix males together, if we mix the sperm from males together, we'll be able to exploit and benefit from the heterogeneity of sperm, from the differences of sperm within each ejaculate as it's mixed up in the straw. So let's go ahead and let's talk just a little bit about the research perspective of heterospermic AI. Research in heterospermic AI has been going on for many, many years. Many years. We're talking 60, 70 years at least. And this research has been focused on and is able to compare the relative fertility among bulls. And it does this by calculating a competitive index based on the proportion of calves sired by a particular bull across heterospermic semen doses. And the idea here is we've taken 2 or more ejaculates from 2 or more males, mixed them, included them in a straw in equal numbers, and then we're placing them in the same environment. They're going into the same female, not into the same herd and herd mates. They're going into the same female and competing. And then that's where that allows us to compare this idea of relative fertility among bulls. And we're able then to calculate that competitive index based on one sire ends up disproportionately as the sire of the majority of the calves. How do we do that? The easiest way, and back in the dark ages, we used phenotype. Okay, very easily. You can use phenotype. You just look at the coat color of the calf, and depending upon which animals you were using, you'd say this is the sire. Now, of course, we have genomics, and that's the SNP chip right there that's being shown. Okay, so heterospermic competitive index is really a research tool. Okay, it's not possible to extrapolate a competitive index to fertility, such as pregnancy per AI or conception rate, because the ranking is relative to the specific bulls used in those inseminations. The strength of this is in estimating, again, that relative fertility of bulls within the mix. But we're not able to speak to absolute fertility of each bull in that mix. So we have to be careful and understand our limitations, but also understand the strengths. And there are strengths to heterospermic AI as a research tool. This competitive index is very good in understanding the relative fertility, but it does not provide us information on the absolute fertility of those males across numerous animals, numerous sites, etc. Now let's look at the commercial perspective of heterospermic AI. We are in a very unique time in the dairy industry and the beef industry. AI-sired beef-on-dairy calves have markedly increased value compared to a purebred dairy steer, dairy bull calf, okay? And what we're able to do now, as far as management strategies, we can genomic test, we can use sex semen, and then beef semen, all within one breeding strategy. The idea is to generate our replacements from the top part of our herd using sex semen. Then we can, with the rest of the herd, or with a significant portion of the bottom part of the herd, breed to beef semen to generate these very much in demand AI-sired beef on dairy, either bull calves or even heifer calves. And AI studs are currently marketing beef sires to dairy producers to generate these F1 calves with desirable characteristics. And just to impress upon you how prevalent this is now, this is a brand new cash flow for dairy producers. And in my area here in southwestern Idaho, day-old F1 calves are bringing anywhere from $600 to $900 day-old. So very, very lucrative at the time. So is this a thing? Is this something that's kind of fringe that only a couple people are doing? And I don't know why I'm listening to this. I could be doing something else instead of being on this webinar. Actually, I've got data here from National Association of Animal Breeders, and they track production and sale of AI doses, whether it's beef or dairy, domestically for the US. And what we're looking at here is an increase in AI doses from the year 2022 to 2023 for beef breeds. So as we look at this chart, and the furthest column on the left, we have breed, and then we have the year 2023 as we go to the right, and then 2022, and then we have percentage change plus or minus. You can see as we go from the top all the way down, the predominant breed that uses or that is used for AI is Angus, not surprising. But look at that second one there, heterospermic beef. Heterospermic beef is the second largest category, if you will, of beef semen that was used in 2023. Okay, even more than Simmental. And we can see if we go down to the lower right-hand corner, it overall beef semen usage has increased 4.6%. Okay. But we know that this semen is not being used in beef cattle. We know that this semen is actually being used in dairy cattle at a higher rate. When we go to a similar table, again put together by National Association of Animal Breeders, we have this table set up the same way as the beef table, except we've got dairy breeds in there. Not surprisingly, Holstein is up at the top and then Jersey. No surprise there. We still have 2023 and 2022. And then we have the percentage change plus or minus. We can see in the lower right-hand corner that usage has gone down 4.24% for dairy breeds. And we can also see that heterospermic dairy is not very popular. Heterospermic beef is really where the growth has been. The heterospermic dairy is offered, but not very popular at this time, at least in this data set. So, what data is available relative to heterospermic AI fertility in cattle? Let's talk about that. So there's no, let me see if I can move this. There we go. There's been no increase in fertility from two different studies when they compared single sire versus a three sire mix. And what I mean by that is we have three sires, and of those three sires, each one is going to be used individually, homospermically. And then those three sires are mixed. The semen is mixed, again, on an equal basis, and that makes the heterospermic dose. So these two studies showed no increase in fertility when comparing a single sire versus a three sire mix. And if we look at an older study done at Colorado State University, this is Nelson, and Nelson worked with George Seidel, who many of you know, and the pregnancy rate of each three sire mix was lower than that of the highest individual bull within the mix in all but one comparison. So what this is telling us is that fertility is comparable. Fertility is comparable, but from these studies, they did not see an increase in fertility from pooled or heterospermic AI. Now let's go ahead and look at some data. This is data from Select Sires. This is specifically in dairy cattle, published in 2008. That's probably why we see fertility down where we do. And essentially what we're looking at is, we're looking at three different bulls, A, B, C, and a heterospermic mix of the three. And we can see that the heterospermic mix is comparable in fertility, but does not exceed the highest fertility bull in the mix. And that's what we see in this ABC and heterospermic graph. And if we go one more table here, Again, this table's set up in the same way the previous one was set up. We have a conception rate on one axis. We have the various bulls, A, B, C, D, E, and then we have the mixed semen. And in this one, we have all doses contain 20 million sperm cells, which is standard for an AI dose. And then using a split ejaculate technique, which is very important. And what that means is the ejaculate was collected, and from that same ejaculate, they generated homospermic doses, and sperm cells went to heterospermic AI. It's a very important way to reduce bias. So they did that in this particular study and the previous study. The heterospermic doses were prepared to contain equal numbers of sperm from each of 5 bulls. So this is a study that used 5 bulls within their mix, and each bull was represented at 4 million sperm cells for 20 million total. Again, the take-home message that you can see here, we have on the far right the fertility level of the heterospermic or mixed, and it is comparable to the individual fertility across these bulls for homospermic inseminations, but it does not exceed what we see of the highest fertility level for the highest bull in the mix. So we see that heterospermic has the opportunity or has the ability to be comparable in fertility. Well, what are maybe some of the potential issues with the use of heterospermic AI? One of the first things we have to talk about is kind of the difference in the way we collect and the way we market dairy semen versus beef semen, okay? We know that about 95% of dairy semen is produced by certified semen services audited facilities. These are facilities that have entered into a voluntary agreement to be audited on a wide variety of things, everything from health testing to semen extenders, antibiotics, a wide variety of things are audited by certified semen services, okay? In some, but not all, custom facilities where we would find more beef bulls being collected, we see a greater disparity of facilities that are certified semen services audited. And that leads us to believe, at least at this time, that we don't have as great of adoption of CSS within the beef industry. Having said that, the majority of beef semen that's being produced, we know is actually being used for AI of dairy cattle. So we have to juggle these two kind of opposing ideas. And I want to encourage producers, dairy producers especially, need to be vigilant in understanding when, where, and how the semen was produced, and the health testing program that was in place at the AI facility. National Association of Animal Breeders and CSS have a great tagline, and the tagline or the advertising line is, "Know your semen supplier." And that's really important. So while these calves are very important, these F1 calves, beef on dairy are very lucrative right now. They have a high price on them. We want to make sure that we are acquiring semen that will offer us good fertility, but will also guard against potential issues, health issues within our herd etc. Okay. So that's one of the things that could be a potential issue is source of the heterospermic doses. Another thing we have to think about is data flow for heterospermic semen. And what I mean by this is when we breed a cow, we're breeding a dairy cow, the semen has the NAAB code, and we write down the NAAB code, and then that data is available and can go into a larger database so that we can understand the success of that sire, what type of offspring they had, what the production capabilities were, etc., the phenotype, etc. What we have with a heterospermic dose, we still have a National Association of Animal Breeders code, just like we would with a homospermic dose. But that NAAB code is linked to a package of a maximum of 6 bulls. So what I mean by that is, if we have 6 bulls, those 6 bulls will get one NAAB code for that heterospermic semen. Okay? And collection centers must record that NAAB code and the information of the bulls that were within that semen straw. Okay, so that's good. And if a bull's removed from that package, let's say we remove bull 6 and we put another bull in, then we have to generate a new NAAB code because the package, the contents of the package are different. Okay. So this helps or contributes to the fact that heterospermic data is not being used in genetic evaluations or statistics on bulls currently. In the future, we'd like to have that, but at the current time, heterospermic data other than a straw was used with this code is not entering into our genetic evaluations or stats on bulls. Of course, genomic testing could be done to identify the sire. It could be, but we have to have these avenues to get the information reasonably efficiently into the system so it can be analyzed. Well, what about the question of, do we need to know the sire of a beef on dairy or of this F1 calf? Some people would argue yes. Some people would argue till they're blue in the face, yes, we need information on genetic evaluation, genetic progress, farm-to-table traceability, trade regulations may require it. Okay? Others might say, gee, I don't really know how valuable that is. Maybe not. No. We're responding, meaning dairy producers are responding to increased demand. And we're developing new cash flow. And people are driving trailers by my place and they're willing to pick up calves day old. One of the things we have to remember is this last bullet point I have here. It's possible that if we don't really think this through, that the dairy industry could lose the premium for beef on dairy calves because we don't continue to produce animals with desirable carcass traits. We really need to have that feedback to understand who the sire was of this calf so that we can keep the system going. A black hide is not enough. Okay, we're turning the corner here, not quite at the end, but we're turning the corner. There's some pretty big news internationally relative to heterospermic AI. There's an ongoing research project in Ireland that's asking the question, Does heterospermic AI result in higher fertility? And this is a collaborative effort between the Irish Cattle Breeders Federation, University of Limerick faculty and graduate students, University College Dublin faculty, graduate students, and Chagas. And they are doing a beef on dairy field trial using 3 bulls of the same beef breed in a straw, that would be their heterospermic doses, versus each sire individually, homospermic doses. Okay, these will all be used at first service, and they'll all be generated using that split ejaculate technique I talked about earlier, which will be able to provide both the heterospermic and the homospermic doses. And then at the end, all calves will be genotyped, and they'll know which males were the sires. So stay tuned. The results will be available in about 12 months. This will be one of the largest, if not the largest study to date on heterospermic. There will be thousands of inseminations within this study. So let's go ahead and wrap things up. I've got quite a few final thoughts here. There's lots of anecdotal data and opinions about heterospermic AI and fertility following heterospermic AI. However, controlled peer-reviewed studies using split ejaculates are very few and very hard to find. And that's really the way we need to look at this, to understand if there are differences or not. Bulls should be represented in a mix in equal numbers. I haven't talked yet about compensable and uncompensable traits, but those of you that have heard me speak before know that's coming. And we have to be careful of numbers. So bulls should be represented in a mix in equal numbers. And high fertility bulls, providing traits of economic interest, should be used in both homospermic and heterospermic doses. There are some issues in other breeds and other animals, turkeys, swine, where heterospermic doses can be used essentially to spread out our ability to use the better genetics by also using males that are a little lower fertility in those doses. And that's not really what we want to be doing. What we want to be doing is identifying as best we can, not only those high fertility bulls, but also those low fertility bulls. Those low fertility bulls, we're pretty good at identifying those, and those need to go. And then from the group of high fertility bulls that provide traits of economic interest, that's where we want to make both our homospermic and our heterospermic doses, and we can make our greatest then progress. What we really have to remember, though, is that quality control at the AI center level is one of the biggest keys to field fertility. And this is a picture from Select Sires. This is a garbage can of semen that didn't make the cut. Okay, one of my favorite pictures, because this is one of those points where you say, it's not going out the door. We don't have confidence that it's going to generate pregnancies. Start over. And that's really where, if we follow strict standards, we can help dial in field fertility. So let's get to that compensable, uncompensable discussion and talk about principles of semen quality control at the level of the AI center. So here's a variation of a graph many of you have seen many, many times, whether I've presented it or if you're a little bit more of an old timer, Dr. Sacchi used to present this. And what we have is we have fertility on one axis, low, medium, and high. And then we have numbers of sperm per dose from low, medium to high. And then we have this dashed line, which is the optimum fertility of the female population. We have a whole bunch of different bulls, bull A through F. And we know as we add sperm numbers per dose, we know that these bulls will approach and some will meet the fertility level of the female population. We also know that some males will not. And those bulls that don't, for example, bull E and bull F, those are bulls that have high percentage of uncompensable traits. And those are bulls and ejaculates that should be culled. And what do I mean by that? The way we use this graph in quality control at an AI center is in this manner. Everything under this rose-colored box is really below the minimum limits of semen dilution. We know we're not going to get acceptable fertility marketing semen that has sperm cells in this range from these types of bulls. On the other hand, bulls that are in this range, even though they have higher sperm numbers, we're going to discard those ejaculates and cull those bulls because, as I said, there's a high percentage of uncompensable traits. Uncompensable meaning we cannot just add sperm cells to increase fertility. And uncompensable traits, if you remember, are really the ones that drive us wild because they compete for fertilization, but they're unable to maintain pregnancies. So what does that leave us with? It leaves us with a very small window for commercial AI, which allows us then, or provides us the ability, I should say, to have acceptable field fertility. And that's really where we need to focus. One of the things that we need to do is we need to have realistic expectations when we engage in new technologies, when we buy new products. And I'm going to go one step further, and I'm going to say we need to resist anecdotal data that may be prevalent in marketing. And what I've shown on this slide within that blue box is something from a marketing pamphlet. It's readily available. It's only a few years old. And it says high fertility pooled semen proven to increase conception rates by 60%. I had to take my glasses off when I saw that, and I thought, really? 60%? And then the line below it says improves fertility by 3 to 6.6%. So I'm shaking my head, trying to clear the cobwebs, cleaning my glasses off. And I'm thinking that first bullet point below there, if we begin with a 50% conception rate, okay, and if we can increase that conception rate by 60%, does that mean we should expect an 80% conception rate? And then that second bullet point, is it possible to improve fertility by 3 to 6.6% and increase conception rate by 60%? I don't have any idea. Okay? We need more hard data, not anecdotal data. We need more data from appropriately designed, peer-reviewed research. Because truthfully, I can't explain what's on this slide. Going on to having realistic expectations, okay? The vast majority of data that is available shows no additive or synergistic effect on fertility has been reported following heterospermic AI in controlled, peer-reviewed studies using a split ejaculate technique. That leads me to the last bullet point, that fertility following heterospermic AI will likely be no higher than that of the highest bull in the mix. Again, inappropriately designed studies that have sufficient number of inseminations. Okay? I've wrapped it up. I'm happy to answer questions at any time. Vitor, turn it back over to you.
All right. Thank you, Joe. Really appreciate the presentation. Really good thoughts. I'm going to open up for questions, folks. So please use the Q&A tab to type your questions. And we're going to go through as many as we can here. So Joe, I'll start with one question. Seems like most heterospermic semen that's sold, it's 3 bulls. Is that correct? Is there
It's
a
very
reason for
common.
that? 3 versus 4, or why is it 3 the magic number there?
Vitor, it's a good question. I couldn't tell you why 3. Research has been done with 2, 3, 4, and 5 are the data. I'm trying to think the data sets that I've seen. I don't believe I've seen a data set that has had 6 in it. So it's a good question. It might have to do, I'm just guessing here. It might have to do with comfort level of numbers of sperm per bull with 3 as opposed to, let's say, 6. Because with 6, if you had 3 million or 4 million or 5 million, as opposed to 3, you could have 3 bulls at 4 million or 3 bulls at 5 million. So you kind of have to work with the ejaculates you have, the males you have, but also the numbers of sperm you have. And that's where I would assume that calculation is made.
No, that makes sense. I wanted to have you kind of go through that thought again of, we've seen an increase in heterospermic semen sales in the beef side. Seems that's a lot of that coming from beef on dairy. So why are we going there? I really love how you look at the data, and it doesn't seem to really have this huge effect. So why are we going back to that?
Another very good question. So first off, beef on dairy is occurring because of the shrinking cow herd, native cow herd in the US. So that's the most basic point there. So then it became, well, we have these technologies and we have the ability to segment up our herd based on genetic merit and use sex semen to generate our replacements. Okay, great. Now we're generating all the replacements we need with sex semen. Okay, now I have these animals on the lower end of my herd that I want them to calve again, and I will milk them, but I don't really want their genetics to be propagated in my herd. So in the past, we would use conventional semen. Some people now are, more than some, are using beef semen. Initially, it was a black hide, and I will get more for that F1 than I do for purebred Holstein or Jersey, something like that. But that puts some price pressure on beef semen, because packers are requiring, or not requiring, packers are demanding, if you will, certain characteristics. And we can't randomly just choose beef sires at whatever the going rate is as dairy producers. So what we can do, an AI center can put in 2 or 3 bulls in a heterospermic dose and can actually charge less for that heterospermic dose, but we can get an appropriate or similar carcass to what is desired at the packing plant. Is kind of where the heterospermic, why that's gone. So it could be, for example, it could be 3 Angus bulls that are very good calving ease, or very good, whatever the marketable traits are, good for ribeye area, etc. And then that makes it marketable to the dairy producer, but it also makes it acceptable to the packer. And it also means we're not, as dairy producers, we're not competing for the homospermic doses, which are usually at a little bit higher price point. Did I answer your question, Vitor?
No, you did. Yeah. No, I think the lowering the prices, I think that's makes a lot of sense, right? But yeah, it was curious, really like to see that it's a huge increase actually from one year to the other, right? And I think that's probably where it's coming from. It makes sense that they can dilute the price of the straw, right, by doing that.
Exactly.
So it makes sense. Very good. Joe, I
Yes.
appreciate you spending Tuesday night with us. Thank you for everybody that tuning in here to watch us. Remember everybody again that we're gonna this is being recorded and we're gonna be posting on YouTube channel as soon as possible. And we'll see everybody on May for our next webinar. Have a good week. Thank you very much. I want to thank again one more time our sponsors, Tech and Merck, for their continuous support. And have a good night. Thank you.
Thanks, everyone.